The last shape that we have to talk about is a sphere, and we're going to talk about the surface area and the volume. So by the end of this lesson, those are the two things you should be able to find. So a sphere is the locus of points in a space that are a fixed distance from a given point called the center of a sphere. So circles and spheres are related because remember that a circle has a center and it has a radius, and then to make the circle you sweep the radius out so that it's all the same distance all the way along, and that's how we draw the circle. A sphere is exactly the same thing but in three-dimensional space. The radius of a sphere connects the center of a sphere to any point on it. A hemisphere is only half of a sphere, and a great circle divides a sphere into two hemispheres. So here's a picture. The whole thing coming out at you is the sphere. It has a center and a radius, just like a circle. Hemisphere is only half of it, and the great circle is the biggest circle you can get out of it. Remember, any of these cross sections will give you a circle, but the great circle is the biggest one, so it goes through the center of the sphere. So here are two more formulas. Remember, you don't need to memorize these. These will be on the test and on the quiz. The surface area of a sphere is 4 pi r squared. So remember, the area of a circle is pi r squared. The surface area is 4 of those. And then the volume of a sphere is 4/3 pi r cubed. And we can prove why that is in class. So find the surface area of a sphere with a diameter of 76 centimeters. Give your answer in terms of pi. So remember, the formula for surface area is 4 pi r squared. So we don't need the diameter, instead we need the radius. So all we have to do is take 76 and cut it in half. So our radius is 38 centimeters. And because they want it in terms of pi, all we have to do is square 38 and then multiply by 4. So we end up with 5,776 pi centimeters squared is the surface area. So if we do another one, find the volume of a sphere with surface area of 324 pi inches squared, and then give our answer in terms of pi. So we eventually want to find the volume, and volume is 4/3 pi r cubed, so we need the radius. But instead of the radius, we're given the surface area, and surface area is 4 pi r squared. So we're going to use that to find what our radius was. So we can divide by 4 pi on both sides. So we're left with the radius squared. And if you do 324 divided by 4, you end up with 81. So then when we go and we take the square root, we can see that we have a radius of 9. And then that's what we're going to plug into the volume formula. 4/3 pi times 9 cubed. And if you cube 9, you end up with 729. And then I'm going to multiply that by 4 and then divide that by 3. So I end up with 972 pi, and it's inches cubed. So if something has a surface area of 324 pi, the volume is 972 pi. Find the surface area of a sphere with a great circle that has an area of 49 pi miles squared. So remember that a great circle is the biggest circle you can make. So that means the radius of the great circle is also the radius of the sphere. So we know the area of a circle is pi r squared, and we need the r in order to find the volume. So we're going to plug in what they give us, that the area is 49 pi. And if we divide both sides by pi and take the square root, we end up with 7 for the radius. And then we can use that and plug it back in. So 7 cubed is 7 times 7 times 7. And then we're going to multiply by 4, and we're going to divide by 3. And we end up with 457.3 pi, and it's miles cubed for our volume. So what happens when we do some other stuff with this rather than just plug and chug problems? So I'm going to leave this one for you to do, but you have two size exercise balls. The standard one that's 22 inches in diameter and a jumbo one that's 34 inches in diameter. You need to figure out how many times greater the volume is of the jumbo ball than the standard ball. So what you're going to have to do is find the volume of both of them and then compare them. So remember, the best way to do that is to divide them, and then I'll tell you how many times you had to multiply to get to the bigger number. So what happens if we change the dimensions? The radius of the sphere is multiplied by 3/4. Describe the effect on the volume. Remember, you can go through and you can plug this in with the information they give you, and then you can multiply this by 3/4 and plug it in and see what you get. But remember, if you have a change, and you change all the dimensions involved, so let's say our change equals A. If you're talking about the area, it's changed by whatever that change is squared. And if you're talking about the volume, it's changed by whatever that change is cubed. So all we have to do is cube 3/4, and that's 3 cubed over 4 cubed. 3 cubed is 27, and 4 cubed is 64. So 27/64 is what your volume would be multiplied by. So let's do some composite figures, putting some of this stuff together. Find the surface area and the volume of this composite figure. Give your answers in terms of pi. Let's find the volume first, because that one's easier. For the volume, we have a hemisphere, which is half of a sphere, and a cylinder. So let's find the hemisphere first. Remember that an entire circle is 4/3 pi r cubed, but we only want half of this. So if we multiply this by a half, we end up with 4/6, which is the same thing as 2/3 pi r cubed. So plug in the only value we need to. We need to plug in the radius. And they give us the whole diameter, which we don't need, but our radius is 6. So if I plug in 6 and cube it, and then multiply by 2, and then divide by 3, I have 144 pi for the volume of my hemisphere. And now I got to do the same thing for the cylinder, and then we got to add them up. Remember, volume of a cylinder is base times height, and the base of a cylinder is pi r squared times the height. So we got two values to plug in here. The radius is 6, and the height of the cylinder is 9. So we'll do 36 times 9, gives us 324 pi inches cubed. So the total volume, once we add those guys together, is 468 pi inches cubed for this composite figure. Now if we want to find the surface area, we got to do some subtracting once we do this. So we have still a hemisphere, but we have to subtract a great circle. And then we have a cylinder, and we have to subtract one of the bases. So when I look at this, I can save myself some trouble by finding the surface area of this whole thing, including this great circle, and then making this great circle count as this circle down here, and then only finding the lateral area of my cylinder. If that makes sense to you, you can do that, or you could do this and subtract one of the bases. So what I'm going to do is just find the area of, or the surface area of my hemisphere, and then I'm just going to find the lateral area of the cylinder. So surface area of hemisphere plus lateral area of cylinder. So my hemisphere, remember that the surface area for a sphere is 4 pi r squared. So because I want a hemisphere, it's only 2 pi r squared. So plug in what we know. We know the radius is 6. So we have 36 times 2, which is 72 pi inches squared. And now, because I'm letting this base that I would have had to subtract count as the base down here, all I need to find is the lateral area around my cylinder. And remember, these formulas will be on your test, but the lateral area of a cylinder is 2 pi r h. Because remember, if you unfold this, you get the circumference of the circle times the height. So 2 pi times the radius, which is 6, times the height, which is 9. And 2 times 6 is 12, and 12 times 9 is 108 pi inches squared. And then all I have to do again is add these guys together. So if we add 72 and 108, we end up with a nice pretty 180 pi inches squared. So my surface area is 180 pi inches squared, and my volume is 468 pi inches cubed. I'm going to leave this one for you to do. It's basically the same thing, but instead of the hemisphere being added to the top, it's being subtracted out of the cylinder. So give that one a try. You should be able to apply the formulas for surface area of a sphere and volume of a sphere. Write down any questions you have and we can go over them together. Enjoy your night.